Observe. Look. Look for asymmetries, lefts and right. Okay? Higher, lower. So this is how you start atoms. Okay? You start in just a basic standing position. If you denote any distortions, primarily Adams looks for lateral curves, okay? But as a part of a lateral curve, if these vertebrae start to shift this way, they'll start to rotate, okay? And it has to do with the facet orientation, so they'll start to rotate, okay, or rotate this, so they'll sweep. So if they start to rotate, what happens to all the tissue that's on this side?
It'll go
It lifts up.
inflamed.
It lifts it up, okay? So you'll also notice one side seems to be more pronounced. Remember the moire photography we showed you, okay? As opposed to the other side. So if you see some distortional pattern, then what you're gonna do is you're gonna have this patient bend over like you're gonna touch your toes for me, okay? And then you wanna look at those same distortional patterns to see if they're varied any, or if they've changed, okay? The idea is that if it goes away or reduced, this is more of a functional issue. So it's an issue of function from a standing to a leaning forward position. Now, you can drop your head for me. Okay. Now come up just a little bit. Stop. Come up a little bit more. Stop.
Oh, sorry.
You see a little bit of increased tone on this side relative to this side. Okay. Y'all see anything up in here? Other than the kyphosis. Right now, because you're behind them, look left to right. A little higher on this side? Right around in here? Okay. Come on up. Stop. Okay. So what you can do is you can get them to roll, okay, and you can look at the different sections. Generally in the thoracic spine, I look at upper, middle, and lower third, okay? And see if there's any differences in the transitional, obviously from thoracic to lumbar also, okay? Come on back up. Just relax, look straight ahead. It does look pretty kyphotic in there, right? Where would you say the apex of his kyphosis is? Probably maybe down right about there, because that's the furthest peak backwards.
Oh, I thought you meant when he was bending over.
No, just right at the moment, okay? So he's got a kind of a kyphosis in that lower third of the thoracic spine. So most of the time the kyphosis apex somewhere in the middle third. Okay. Sometimes it's higher up, sometimes it's lower down, but generally it's in that middle third. Okay. That also tends to be where they transition in coupling patterns for lateral bending. Okay. So we generally say T6 and up follows the cervical spine, T7 and down tends to follow the lumbar spine, when lateral bending is your primary motion. Okay? So lateral bending is always coupled with what? Rotation, okay, to a lesser degree. Right? So if you could get pure rotation, then lateral bending would be the secondary to a lesser degree. Okay. The problem is you can't get really pure rotation because we've got all these curves in here. It's really hard to rotate around the y-axis perfectly, okay, without some compromise, and that's your couple. Okay. So those are things we look at. What we can also look at is we can measure those with that little scoliometer. Okay. If you have an inclinometer with a real flat bottom, okay, that's kind of broad, you can do that also. Generally have a little cutout for the spinous, so it kind of sits. You want it to sit on this mass and this mass, and take your measurements. Okay. In fact, if you will hand me one of those things in a bag. Now, I would have broader feet on this, but I could certainly use something like this. Would you have you go forward a little bit again for me? Stop. So. That way you can measure your deviation. Okay. So if it's a lot higher on one side, we can tilt like this. Okay. And like I said, I'll usually do a lower, middle, kind of an upper third. Okay. But an inclinometer is the way to go for that. Come on back up. All right. So just check each other out real quick. Okay.